Hey guys, today we're going to have a look at the volumes and surface areas of prisms. Now don't worry, this shape that we've got here is not a prism. It's some type of very complicated polyhedra, and prisms are types of polyhedra as well, but prisms have a lot more symmetry in them, so they're going to be a lot easier to work with. Let's get started with the basic formula for the volume of a prism, and this works for any type of prism. It's just the area of the cross-section multiplied by the length of the prism. Let's have a look at this rectangular prism. I'm going to call this yellow face here my cross-sectional face. And a cross-sectional face by definition has the same shape and size as the opposite face of the prism. So on the other side of this rectangular prism, I also have a face which is 3 wide and 2 high. Now this prism is 3 wide, 2 high, and 1 long. The volume of a prism can easily be worked out by just working out the area of the cross-section, which we know is the length times the width. So 3 times 2, I can see that here, 1, 2, 3, 4, 5, 6, and then we multiply that by the length of the prism, in this case 1. But if I were to make that prism longer, you can see that the volume of that prism is still equal to the area of the cross-sectional face multiplied by how long the prism is, so the distance between the two cross-sectional faces. And that's the same for any type of prism, not just rectangular prisms. Now here are 2 rectangular prisms to get us started. These are the easiest types of prisms to work with because it really doesn't matter which face I call the cross-sectional face because there's so much symmetry. For now, I'm going to call the yellow face the cross-sectional face. So the volume of a rectangular prism is the area of a rectangle because that's the shape of our cross-section, base times height, and multiply that by the length of the prism. The length of the prism being the distance between the shape that we've called our cross-sectional face and the opposite side of the prism, where we'll see our other exactly identical cross-sectional face. So for this first example over here, we're going to do the area of this yellow cross-sectional face, which is 3 by 2, and we're multiplying that by the length of the prism, the distance from this yellow face to the opposite side of the shape. So that's 1. That's going to be 6 times 1, which is 6 centimeters cubed. We're talking about volumes here, which are 3-dimensional measures, so we measure them in centimeters cubed, 3-dimensional units. Okay, for this one over here, same idea. We're doing the volume of a rectangular prism, so we're going to do the area of the rectangular face, that yellow cross-sectional face that we've identified here, multiplied by the length of the prism, which is the distance between that face and the opposite side. So I'm doing this area, which is 3 by 2, multiplied by its distance to the other cross-sectional face, which is identical to the one we identified over here, which is a distance of 5. So 3 times 2 times 5, that's 6 times 5, which is 30. And again, we're talking about 3-dimensional measures here, so centimeters cubed. Now this is not just for rectangular prisms, however. When we're looking at triangular prisms, we're using the same basic formula. The volume of the prism is the area of the cross-sectional multiplied by the length of the prism. But this time the cross-section has got to be the triangular face because it's the only face that we can clearly see repeats itself on the opposite side of the prism. If I were to say that the red rectangle over here was the cross-sectional face, you can see I'll have made a mistake because on the opposite side of that triangular prism, we don't see an identical red rectangular shape. Okay, so this is my cross-sectional face, which means I'm going to need to use the area of a triangle for the area of the cross-sectional face. Same with this triangular prism over here. This has got to be my cross-sectional face because this is the shape that I see repeated on this side of the prism as well as on the opposite side of the prism, which is hidden back there, not the rectangular faces. Right, so starting with the formula for the area of a triangle then. The volume of a triangular prism will be the area of the triangle, which is base times height divided by 2, multiplied by the length of the prism. The length, again, is always the distance between the two cross-sectional faces. So in this case, the length of the prism is 1, 2, 3 squares. In this case, the length of the prism is just 1 square. So for this one, the volume of this triangular prism is going to be the base, which is 2, times the height, which is also 2, divided by 2 because it's a triangle, multiplied by the length of the prism, which was 1. So that's going to be 2 times 2 is 4 divided by 2 times 1. And 4 divided by 2 is 2, so that's 2 times 1, which is 2, again centimeters cubed because this is a volume. With this other diagram over here, again, same formula. We're doing base times height divided by 2 times the length of the prism. The base of this triangle is also 2. The height is also 2, divided by 2 because it's a triangle, and multiplied by the length of the prism, which was 1, 2, 3. So that's going to be 2 times 2 is 4 over 2. 4 divided by 2 is 2, so that's 2 times 3, is 6 centimeters cubed. So if I open this up for you, you can see all of the faces together. You can see my 2 yellow cross-sectional faces, but you also see my white and pink faces, which wrapped around the yellow face when it was all closed up. Now this is the net of the prism. So I've unfolded it open and laid it out flat so you can see all of the faces all together. But if I close that back up, you'll see that all of the other faces wrap around the cross-sectional ends of the prism. So that means that while I got 2 rectangles on either end, and I have 4 rectangles through the middle here, I could actually call this middle rectangle one big rectangle, where the length along this side here is equal to the perimeter around the cross-sectional end. That's why we can say that the surface area of any prism is equal to 2 times the areas of the cross-section plus a rectangle which has got a length equal to the perimeter of the cross-sectional face and a width which is equal to however far apart those cross-sectional faces are. So the area of this surface area of the prism will be 2 times the area of the cross-sectional face plus this, which I've put in square brackets here. The reason I put those square brackets on there is because when I unrolled that prism into this shape, I see my 2 cross-sectional faces and I see this one big rectangle. I can work out the area of that rectangle all in one go. So I've put it inside these big square brackets. Let's try this for this example. The surface area is going to be 2 times the cross-sectional face area. So that's 2 times, and this is 3 times 2, plus the perimeter of this cross-section, so that's 3 plus 2 plus 3 plus 2, which you can also see over here is 3 plus 2 plus 3 plus 2, and we multiply that perimeter by the length of the prism. That's the 5 here, or as you see over here, that's the 5 there. So I'm doing 2 times this area of the cross-section, 2 times 6, plus I'm doing the area of this big rectangle here, and you can count it here. That side length is 10, that side length is 5, so I'm doing 10 times 5. And that's going to be 2 times 6, which is 12, plus 10 times 5 is 50. 12 plus 50, that's 62 centimeters squared. We're talking about surface area now. This is a 2-dimensional measure. We folded it out flat into a 2-dimensional shape. So that's 6.2 centimeters to the power of 2 squared. Now this shape as well, we could work out the surface area of this one by unfolding it. Or we can just look at it as 2 times the area of the cross-sectional face plus the perimeter of that cross-sectional face multiplied by the length of the prism. So that's going to be 2 times 3 times 2, which is this area here, plus the perimeter of this prism is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's this here. And we're multiplying that by the length here, which is 1. That's going to be 2 times 6 plus 10 times 1, which is 12 plus 10, 22 centimeters squared again. Square area. Let's make sure we sum up our note on these formulas before we move on to rearranging them. So the volume and the surface area of a prism. Regardless of which one you're looking for, first thing you should do is identify the cross-sectional face. And once you've identified the cross-sectional face, you can then also decide what is the length of the prism. It's the distance between the 2 cross-sectional faces. Once you've figured that out, you can use the formulas. The volume formula for a prism is the area of that cross-sectional face that you've identified multiplied by the length of the prism that you've identified. The surface area of a prism is 2 times the area of that cross-section that you identified plus, And I'm putting this in square brackets here so that we remember it's because we made one big rectangle where the length of the prism is the length of the rectangle, while the width of the rectangle is the perimeter of the cross-sectional face that we have identified. Okay, so now that you've got those formulas, we can use them to rearrange. Reversing the formula, you're going to want to copy this diagram down and copy this question into your theory book. Given that this rectangular prism has a volume of 120 centimeters cubed, work out the missing length L, which I can see is labeled on here, and the surface area. Now, in order to do this, you should always start with a formula. You're given the volume in the question, so you should be writing the volume formula. The formula for volume is the area of the cross-section multiplied by the length. So I have some of these values. I've got the values that I need to maybe work out the area of the cross-section, but I am missing the length. So I'm not going to be able to just substitute into this equation and solve, but I can substitute into this formula, make it into an equation because I know what the volume is, and rearrange it to solve. So the equation that I'm going to solve, the volume which I was giving was 120, the area of the cross-section, and I'm choosing this to be the cross-section because I think that's going to be easiest. I know the values I need for the cross-section. So 3 times 5 multiplied by the length L, and I'll rearrange that to find L. 3 times 5 is 15. So to get L on its own, I need to move the 15 to the other side and divide by it. And 120 divided by 15 gives me L. L is going to be equal to 8 centimeters. So now that I know what the length is, I can replace the L on the diagram with an 8, and I can go on to solve the rest of this question. Remember, we're working out the missing length L and the surface area of this rectangular prism. So now that I have all of the lengths necessary to work out the surface area, I just need to set up the formula and substitute into it, and then I've got my solution. So my formula, the surface area is 2 times the area of the cross-section. Now remember, I used this as the cross-section before, so I'm going to continue to use that cross-section again. So 2 times this area is 2 times 3 times 5, plus the perimeter of this cross-section multiplied by the length. So the perimeter of this cross-section, 3 plus 5 plus 3 plus 5, multiplied by the length, which I worked out was 8. Okay, so we've got 2 times 3 times 5 plus my perimeter times 8. Simplifying that, I've got 2 times 15 because of the 3 times 5. My perimeter, adding that up, works out to be 16 times the 8, which was the length. So that's going to be 30. 2 times 15 is 30, plus 16 times 8 is 128, and that works out to be 158 as my centimeters squared as my surface area. Remember, surface area is a 2-dimensional measure, area, square area, centimeters squared. Let's try another one. This time, they're giving us the surface area. So given that this rectangular prism has a surface area of 100 centimeters squared, work out the missing height and the volume. Okay, so this time I'm missing the height. Let me choose my cross-sectional shape to be the bottom this time because I know the measurements of the bottom, 4 and 2. I don't want to choose this as my cross-sectional area because then I'm going to have to use h too many times in the formula and it's going to get confusing. So my cross-sectional area is 4 by 2. Now I want to work out the volume of the shape, but they gave me the surface area, so that's the formula I need to start with. Surface area is equal to 2 times the area of the cross-section plus the perimeter times the length. Let's start substituting into that. I know the surface area, so this is going to become an equation. 100 is equal to 2 times the area of the cross-section. Remember, I chose the cross-section to be this 4 by 2 area, plus the perimeter of that cross-section, which is 4 plus 2, plus another 4 plus another 2, times by the unknown height. That's my length of the prism, the distance between the cross-section on the bottom and the cross-section on the top. Okay, so simplifying this, I've got 100 is equal to 2 times, that will be 8, plus my perimeter, that simplifies to make 12 times h. So this is going to end up being 100 equals 16 plus 12h. To get the h on its own, let's move the 16 across. 100 minus the 16 is 12h. And 100 minus 16 is 84. Then I move my 12 across. It was multiplied, so I'll divide. So I've got h must be equal to 7 centimeters. Now that I've got h, I can use that with the formula for the volume. The volume formula is just the area of the cross section, which I've chosen to be 4 by 2, multiplied by the distance between the cross sections, that's the height, h. And I've already worked out the h was 7. So that's going to be 4 times 2 multiplied by 7. That's going to be 8 times 7, which is 56 centimeters cubed.